Hello everyone, my name is Surjya Sankar Roy, roll number 22ME10086, and I am excited to present our solution to the mechanism sessional lab assignment 5. Along with me are my group members Kshirod Kalet 22ME10046 and Shital Mandal 22ME30062. Let us start the presentation. We have designed a 3D model of a garage door mechanism that does not have any prismatic or higher kinematic pair and occupies less space to remain open. We have used two softwares, MATLAB for synthesis in both 2 and 3 dimensions and plotting graphs, and Autodesk Fusion 360 for making the model. You can view the model on the right hand side of your screen. Let us overview our solution starting with the approach. We first use the method of 3-position synthesis on pen and paper for studying the problem. The basic structure of 4R linkage is shown on the screen on your right hand side. We synthesize the 4R mechanism in two ways. First, we can fix C and D in 3 configurations and find the ground hinges A and B subsequently. In a reverse way, we can fix A and B and find the position of C and D by inverting the door D in 3 different configurations. Here we assume the door to be an extension of link C.
Hello everyone, my name is Kshirod Kalet and my roll number is 22ME10046. In this, we have used two softwares. First one is Fusion 360. In this, we have used 4 features: 3D modeling and design, assembly design, simulation and analysis, large assembly handling. And second software is MATLAB. In this, we used mechanisms analysis, graph generation and visualization, simulation and analysis. For MATLAB program, for 2D, there are 3 parts of code. First one, assigning value from graphical synthesis, simulation and plotting of mechanism. For 2D, this one is for simulation and plotting. And for 3D, this one is for synthesis and plotting. For synthesis, first, as mentioned in the overview, we first fixed point C and D on the door in different configuration. Point C and D rotate in a circular arc about the ground hinges B and A respectively. Ground hinge A will be the point of intersection of perpendicular bisector of D1, D2 and D2, D3. Similarly, ground hinge B will be the point of intersection of perpendicular bisector of C1, C2 and C2, C3. After getting the position and the ground hinges, we note that the length of links and angle are as needed. For synthesis 1, 2D and 3D images plotted from MATLAB is shown, and the remark is the path generated by the end of door takes much space which is not desired. We tried again with a different intermediate position of the door, hoping to get closer to desired result. For synthesis of second, we followed the same procedure for mechanism 1 with a different intermediate position of the door. We observed that though the mechanism became a bit better, the space that door covers was still large. Link length as seen by graphical synthesis, EF is 10, CD is 4, CE is 4, DF is 2, AD is 4.8, BC is 5.6 and AV is 2.4. It should be noted that the garage door in this case is better in terms of minimal area swept than the previous one. However, the length of links connecting the ground hinges and the door is considerably large. This will exert immense torque on these links and they might buckle or yield. For synthesis of 2, it's given 2D and 3D images from MATLAB, and the remark is the mechanism reduces the area swept by the door considerably. However, the length of connecting link is quite large, which is an issue. Here we can see area swept by synthesis 1 and 2. On the left side it's for part 1 and for Second part on the right side. As you can see, these are perfectly fine working mechanism. However, the area swept by this mechanism is not very optimal and can be reduced by modification. And a major problem with this mechanism, it should be noted that the length of links connecting the ground hinges and the garage door is considerably high. Hence, a lot of torque will be acting on these links. This might result in bending or buckling of links.
Hello everyone, my name is Shital Mandal, roll number 22 ME29002. So far, we have synthesized two mechanisms. Both mechanisms are functional models and take up minimal space. However, the links connecting the ground hinges to the garage door are excessively long, leading to significant torque acting on them. To resolve this issue, we aim to develop a mechanism that occupies less area and features considerably shorter link lengths. The steps we follow are as follows. As mentioned in the overview, we first fix the ground hinges A and B to determine the position of C and D. Then points C and D rotate around the points B and A respectively, following a circular arc. Then we analyze three different configurations of the door. Then by grounding the door and observing the movement of points A and B, we can identify the position of C and D. To achieve this, we invert the second and third configuration of the door onto the first configuration, obtaining position A2, A3, B2 and B3, while A1 and B1 were initially assumed. Point C is located at the intersection of the perpendicular bisector of B1, B2 and B2, B3. Similarly, point D is found at the intersection of the perpendicular bisectors of A1, A2 and A2, A3. Once points C and D are determined, we record the link lengths and angle as required. Let us see the synthesis 3. The same procedure is followed as mechanism 3 to synthesize the linkage. However, we only change the relative position of the ground hinges and the intermediate position are adjusted to create an improved linkage design compared to the previous version. Link lengths obtained from the graphical synthesis are EF is equal to 10, EC dash is equal to 5.3, C dash is equal to 3.3 and so on. Then we put the link lengths into our MATLAB program and generate the simulation of the 2D and 3D mechanism. Here we can see that connecting length of mechanism is relatively small. This is the area swept graph of the mechanism 3. From the synthesis, it is evident that the connecting links are relatively short. This results in reduced torque acting on the links and a lower likelihood of buckling. Additionally, based on program observing the bottommost point of the vertical door as the origin, we observed maximum displacement of the door towards the left is 4.9 and maximum upward displacement of the door is 11.4. This information is crucial for ensuring the proper construction and the functionality of the garage door. Here we see that the area swept by the door is considerable and connecting link lengths are relatively small, which is a big advantage.
Hello guys, this is Surjya Sankar, and now let us see the Fusion 360 model of the garage door. You can see the garage door, which is brown in color, and it is attached to the frame, which is grey in color. You can see the joints and the revolute pairs that are helping the door to rise up and come down. Now let us check out the results of the process that we have followed up till now. Mechanisms 1 and 2 occupying less area, but the lengths of the connecting links are quite large. Hence, there can be an excess of torque acting on them and they may face buckling or bending. However, mechanism 3, which occupies less area to open and has shorter connecting links, hence the torque acting on it will be less and there will be lower chances of bending or buckling. So the optimum simulation among the three is mechanism 3. Let us think about the future ideas that we can implement on this project for greater innovation and efficiency. First, we can use vision detection or RFID tags or even Bluetooth beacons or a combination of the above to detect authorized vehicles approaching and automatically opening the door in that case. We can use it in case of family vehicles, our own personal vehicles, or even the vehicles of a particular corporate company. We can also incorporate an electromagnetic catch to disengage the motor for manual operation during power outages or malfunctions. This serves two purposes. First, it will give us a dual functionality mode, and second, as mentioned, it will prevent working. It will prevent stoppage during any malfunctions possible. Next, we can integrate ultrasonic sensors or infrared beams on the outer surfaces of the door to detect objects or humans or animals under the door. Then we can use a feedback loop to immediately reverse or stop the door, preventing damage to both living or non-living property. We can use a mechanical lever coupled with feedback sensors to notify the system when it's in manual mode, preventing conflicts with automatic commands. For this, we can also generate a priority chain of commands. Lastly, we can analyze the minimum torque created in this process and proper clearance of the door for real life usage so that it can be implemented in the natural environment. Now, as the presentation comes to an end, we thank you all for bearing us with us through the presentation, and we thank Professor Anirban Dasgupta and Professor Vishwajit Bharat for taking the wonderful mechanism sessional laboratory class.